Dear students, in this session we are going to discuss about waste products and byproducts obtained from sericultural industries and their utilization, and also rearing of non-mulberry silkworm. Accordingly, first let us discuss about the byproduct utilization from silk industry. Apart from silk, there are several other byproducts obtained from sericulture. The mulberry fruits are rich in minerals and vitamins, and from the roots, barks and mulberry leaves, several Ayurvedic and herbal medicines are prepared. Some of the woody mulberry trees provide timber which are resistant to termites, and the timber is used for making sports items, toys, etc. The mulberry branches after silkworm feeding are generally dried and used as fuel, particularly in the villages. The foliage of mulberry is used as a fodder for cattle. The mulberry trees are also planted in the embankment area for protection of the soil to prevent soil erosion, and mulberry trees are planted as avenue trees. The silkworm pupae are rich in oil content, and pupal oil is used in cosmetic industry, and the remaining pupal cake is a rich source of protein suitable for poultry and fisheries. In some tribal population, the people eat eri pupa as a source of protein and nourishment. The silkworm litter is used for biogas production and used as a fuel for cooking in the rural area. Thus, sericulture not only provides silk for fashionable clothing, it also provides several very useful byproducts to the human society. Therefore, sericulture development provides opportunities to improve the living standards of people in the rural area in developing countries. Now, let us know about the byproducts in sericulture. In sericulture, nothing goes waste. Both the on-farm and off-farm sectors of the industry have potential to convert their waste into useful byproducts of commercial value. There is a possibility of value addition up to 40% by proper utilization of the sericulture and silk waste. In China, mulberry fruits are used in the manufacture of tasty juice, wine, and jam. Mulberry stems in the preparation of fine quality handmade paper, silkworm pupae and moths to prepare medicines, vitamin E, and poultry feed. Male moths are an integral part of the traditional Chinese medicine for sterility. Components like chlorophyll, keratin, phytol, pectin are extracted from the silkworm feces for use in the manufacture of edible colors, candy, wine, ice creams, and medicines for gastric ulcer, liver and blood diseases, and the triocantanol for use as a plant growth regulator. The silk powder is said to be helpful in reducing cholesterol and blood pressure, while the silk films are used as artificial blood vessels, skin, and vectors for medicines. In India, the use of mulberry leaves and fruits in medicines and food, extraction of oil from silkworm pupae, conversion of different silk wastes into useful products, cut and pierced cocoons in handicrafts are practiced. Pruned twigs may be used for fuel purposes. Mulberry tea is produced from the leaves. Bed refuse from silkworm rearing is used as cattle feed. Secondary waste or byproducts of an industry are often brought to purposeful utilization to augment the profits. This vital aspect so far seems to have been neglected in tussar industry. Cocoonage acts on gummy substance of the cocoons and hydrolyzes it into amino acids. Then cocoon fibers become loose and can be reeled, and pupae from the cocoons will be obtained, from which can be further utilized for moth emergence, coupling and egg laying. The present process of reeling kills the pupa, which are thrown away without any utilization, though they are rich in proteins, carbohydrates, oils and minerals. Students, now let us see the present scenario on utilization of the byproducts obtained from silk industries. A proper utilization of secondary waste products of silk industry can generate extra income in addition to the silk, the main output in sericulture industry. Major wastes of silk industry are sericin, pupae, pupal skin, moths, silkworm excreta and silk fiber waste. Realization of waste during mulberry and non-mulberry silk reeling is quite high, that is about 35 to 40% of the raw silk reeled, and availability of mulberry dry pupae in India is approximately equal to raw silk production of 16,525 tons. Pupae can be properly used to extract oil to the extent of 20%, that is 3,305 tons. A large quantity of waste accumulates in the silk reeling process. In India, reeling could be utilized to produce value-added byproducts with the adoption of improved technology or process, and the cost of silk production can be reduced by utilizing the waste of the silk industry. Sericin powder can be prepared or extracted from silk industry waste water, which can be a valuable ingredient for food items. The pupal skin, which is available abundantly in the reeling and grainage industries as a waste, can be utilized as a high potential commercial raw material for various industries including pharmaceuticals. Silkworm pupae provide a source of human food and poultry feed. Their nutritional values are astonishingly high, containing large quantities of proteins, fats, carbohydrates and vitamins. It has been optimized for use in cosmetic powders, and it is also being used in production of soaps, shampoos, rinses and setting lotions as silk proteins, which have excellent properties such as giving the hair elasticity, luster and firm lasting shape. The silkworm excreta provide a source of manure for agricultural products. Silk fiber waste obtained during processing of cocoons and reeling operations can be suitably used for conversion it into spun yarn by spinning process. It has been evaluated that secondary waste products of silk industry can be exploited industrially in order to earn more profit in Indian sericulture industry. India is a second largest producer of silk in the world, next to China, and has a 13.4% share in the global raw silk production. A major concern of the silk industry is the need to make the most efficient use of natural fibers, particularly in terms of utilizing waste products of silk industry. Silk waste itself arises from damaged cocoons or from cocoons which are difficult to unreel, together with waste fiber from processes preparatory to spinning. Students, now let us discuss about the waste generator in silk sector. The main object of silk industry is to produce silk cocoons by rearing the silkworm and produce raw silk. During the conversion or the processing of cocoons into raw silk filament, generation of waste at every stage is inevitable. The secondary waste products of silk industry are sericin, pupae, pupal skin, moth, silkworm excreta and silk fiber waste. Waste generated during various stages of silk production are the floss, which is generated during the deflossing of cocoon, then the defected cocoon like double cocoon, stained cocoon, malformed cocoon, flimsy cocoons, etc., which are sorted out before reeling, cut and pierced cocoons which are produced during reproduction, peduncle waste from tussar cocoon, waste generated during cocoon reeling and re-reeling, and the large quantity of waste that accumulates in silk reeling process in India could be utilized better to produce value-added byproducts. During rearing, pierced cocoons and double cocoons are created. Silk reeling generates brushing waste, end missing cocoons, and pupae. Other rejected cocoons and waste are reprocessed into flow silk and spun silk yarns. The total raw silk production and silk waste of mulberry is higher than that of non-mulberry silk. But during 2001 and 2 to 2005 and 6, decreasing of generated mulberry silk waste due to development of efficient cocoon cooking and reeling machines. Students, now let us see about utilization of secondary waste products of sericulture and silk industry. Some prominent secondary waste of sericulture industries are sericin, pupae, pupal skin, moths, silkworm excreta, silk waste fibers. Let us know about each one of them in detail. Sericin was extracted with 75% ethanol to obtain crude powder. A novel effective technology for preparation and characterization of sericin powder extracted from silk industry wastewater or degumming wastewater, which is important for potential application of sericin to food manufacture. Silkworm pupae are a byproduct of reeling industry, and it is estimated that in case of mulberry silkworm, annually 1.5 lakhs tons of pupae are produced, which is generally waste material. In some parts of India, the silkworm pupae are regarded as delicious food for human due to their nutritional values. In dry airy pupa, the main constituents of airy pupa are found to be 62% crude protein, 44% soluble protein, 25% total lipid, and 5.2% ash content. Sericulture is performed traditionally by the tribal communities of Assam, and they rear airy silkworm for obtaining silk for clothing and to consume pupae as food item. The different items of cuisine that can be prepared out of airy pre-pupae and pupae include fry, pakori, cake, etc. The oil portion of airy pupa can be extracted from dry pupae powder by solvent extraction method. Airy pupa oil can be utilized in food industry as well as the source material for oleochemical industries. Waste silkworm pupae generate vast resources of nutrients for livestock and poultry. Silkworm pupae are one of the unconventional top-class proteins and lipid feed, which is a waste product of silk industry and is obtainable 4 times in a year. The effects of silkworm pupae on growth and egg production performance are good. The efficiency by the birds receiving silkworm pupae was also better as compared to the control. The study demonstrated that cheaper waste silkworm pupae could be an excellent substitute of costly protein concentrate in formulating diets for layers, leading to increased profitability. In poultry production, the performance of chickens' growth, egg production, and profitability almost linearly increase up to 6% due to the supplement of sericultural dietary levels. In sericulture industry, the most generated waste is the pupae, which can be utilized as inoculums in the fermenting media to produce protease enzyme through submerged fermentation. In Karnataka state of India, it is estimated that fresh pupa available from cocoons, that is about 80% weight of cocoon, and pupal skin available from dry pupa, that is about 2% weight of the dry pupa, which is available abundantly in the reeling and grainage industries as a waste, can be utilized as a high potential commercial raw material for various industries including pharmaceuticals. The silkworm excreta provide a source of manure for agricultural products. The silk waste from the bivoltine can be reutilized by extracting the fibroin powder using either formic acid or calcium chloride, which may find many uses in diversified fields like pharmaceuticals, food industry, cosmetics, and biomedical fields. The natural silk waste solution was prepared using a high frequency electromagnetic field which have been used to improve the properties of the locally produced polyacrylonitrile fibers. Now let us discuss about rearing of non-mulberry silkworms. The different non-mulberry silkworm species are eri silkworm, which is scientifically called Samia cynthia racini, the tussar silkworm, scientifically called Antheria melita, and the muga silkworm, Antheria assamensis. Let us get to know about sericulture first. The rearing of eri silkworm is known as sericulture. It is the only domesticated non-mulberry variety. Eri fabric is commonly known as poor man's silk. The adult moth of eri silkworm is stout and dark, and the wings are darkish brown and white. It lays 120 to 200 eggs in clusters which hatch in 7 to 10 days. The caterpillar has a green body with a brown head, and the body has small tubercles bearing short hairs. The full-grown caterpillar is 8 cm long, and the larval stage lasts for 17 to 25 days. The caterpillars feed on castor leaves. Among the food plants, castor is much preferred host due to higher water content, ash, nitrogen percentage, acidity, and crude protein. It can pupate anywhere, so no chandraki is necessary. The cocoon is not in one single strand, therefore not reelable, and to emerge from the cocoons, and after emergence the cocoons are reversed to remove the pupal cases. The cocoons are then soaked in cold water for 18 hours, in warm water for 45 minutes, washed in washing soda solutions, dried and spun into silk. 28 grams of eggs will give about 1600 larvae, which can yield 4 kg of silk after consuming leaves from about 0.5 hectare of castor crop. The different methods of rearing of eri silkworms are incubation, brushing, feeding, molting care, spacing, bed cleaning, mounting, harvesting, and spinning. Let us know about each one of them in detail. Incubation. One disease-free laying contains about 300 eggs. Eggs laid by the female on the first 2 days are selected for rearing. The eggs are treated with formalin 2% on 4th day. Keep the eggs in bamboo trays covered with wax paper. Incubation at 22 degrees C with high humidity favors percentage of hatching. Then brushing. Tiny worms tend to remain together and do not easily move out. Provide tender leaves. The worms cling onto the undersurface. Transfer the leaves to bamboo trays. The next step is feeding. For this, provide older leaves to the grown-up worms. The leaves should be dry and dust-free. Avoid yellow leaves. For the first instar, give 5 feedings per day, including night. From 4th instar stage onwards, give 3-day feedings and 1 night feeding. Then molting care. It includes by following all the care recommended for mulberry silkworm rearing. A slight lowering of temperature in the beginning and a little increase in humidity towards and end of the molting is recommended. Spacing. A proper spacing helps in better growth and avoids disease epizootic. In the first stage, the development of the worm is most rapid. Provide spacing 2nd day after hatching. Adjust the operation along with the bed cleaning. Worms require 3 times the space occupied by its body. Bed cleaning. 3 methods of cleaning are carried out. Cleaning with half burnt paddy husk or only husk, net cleaning, and the third one is husk and net method. In paddy and husk method, a thin layer of husk is sprinkled over the bed. The worms rise above through the husk. It is used when the bed is damp in moist season. Net cleaning method. This method is similar to that of mulberry silkworm net cleaning. Then the third is husk and net method. It is the combination of both paddy and husk method and net cleaning. Worms are lifted after 2 feedings and transferred to another tray. Mounting. This involves transferring the mature worms to bamboo baskets loosely filled with dry paddy straw. Worms spin cocoons in between the folds. For this purpose, provide proper ventilation. In case of harvesting, worms complete spinning on 3rd day and so collect the cocoons on 5th day. Spinning. Eri cocoons are open-mouthed and not composed of continuous filament. They are not reelable. Cocoons are boiled in soda of potash for degumming. After degumming, cocoons are put in bags and boiled in water. Later, cocoons are washed in cold water for several times and shade dried. Cocoons thus prepared can be spun in wet condition with the tuckli and in semi-dry condition with the hand charka, that is spinning wheel. Students, now let us discuss the rearing of tussar silkworm. Tussar silkworm is wild and reared outdoor. Tropical and temperate tussar silkworms are reared in India. Tussar silkworms are univoltine, bivoltine or trivoltine. They undergo pupal diapause. At present, 0.56 million hectares of forest is covered with tussar silk production, while an estimated 11.16 million hectares of forest land has been identified as eligible for cultivating tussar silkworm. Madhya Pradesh, Orissa, Andhra Pradesh, Maharashtra, Bihar, Karnataka and West Bengal have the food plants capable of breeding tussar silkworm. Tussar silkworm is also a sautanid moth usually found in forest areas feeding on the trees like Dalbergia, Shorea, Terminalia, Ziziphus, Ficus, etc. But the more important hosts are Shorea and Ziziphus mauritiana. Eggs are laid on tender leaves of the host trees and the moth lays about 200 eggs. The egg stage lasts for 8 to 10 days. The caterpillars are stout green with red spiracles and the larval period is 35 to 70 days. Cocoons are oval and as large as a hen's egg with a hard case hung from the terminal branches with a still attachment about 5 cm long. Pupal period is 25 to 50 days. The moths do not mate in captivity, so caterpillars cannot be domesticated. As such, the cocoons have to be collected from the host trees in the jungle. The silk is reelable unlike that of this eri silkworm, and therefore the pupa have to be killed before emergence of the moth to prevent cutting of the silk thread into pieces. The tacinid oozy fly parasitoid causes a loss of crops up to 30 to 40%. The fly lays 250 to 300 eggs at the rate of 10 to 30 eggs per larvae, preferably on 3rd to 5th instars. Turpentine oil repels the oozy flies at the site of rearing. Natural enemies of tussar silkworms are the ichneummonid parasitoid Xanthopimpla punctata and the praying mantis Hyridola bipalpala. In the commercial production of tussar silkworm, first let us learn about the establishment of host plants. For this purpose, Terminalia arjuna saplings are to be planted at 1.2 into 1.2 meter spacing, which becomes suitable for rearing within 3 years. Keep the plantation at 2 to 3 meter tall by pruning. Terminalia plantation should be kept clean and the base of each tree trunk covered with any insecticidal dust to prevent the dispersal of the ants from soil to tree. Remove the red ant colonies, that is Ecophylla, in the tree to avoid predation on young larvae. The above spacing is effective with a leaf yield of about 18,000 kg per hectare after 4 years from plantation capable of sustaining about 450 DFLs, that is disease-free layings. This type of plantation is termed as economic plantation. Okay, now let us know about brushing in case of rearing of tussar silkworm. Newly hatched larvae can be directly transferred to tree branches. A small twig should be placed over each newly hatched larvae and then tied on the tree for uniform distribution. The first installed larva can be reared under controlled conditions on cut twigs kept in a cage. The bottom of the twigs should be immersed in water kept in a bottle or earthen vessel to prevent quick drying of leaves. The rearing of larvae can be taken up to third instar under nylon netting. Fourth instar can be transferred to forest plantation. Molting of first to fourth instars occur in 3 to 4, 5 to 7, 7 to 8 and 8 to 10 days respectively, while the fifth instar takes 15 days of voracious feeding to become full grown when it measures 12 to 15 centimeter and weighs 45 to 50 gram. The cocoons are collected by tribals and stifled. Stifling and reeling of tussar cocoons. Tussar silkworm cocoons are rather hard and hence they are first soaked in 5% sodium carbonate solution for 18 hours. They are then subjected to steam cooking in pressure chamber for 2.5 hours. After 24 hours, the cocoons are washed in 0.5% formalin for 15 to 20 minutes. These steps give silk fibers a greater tensile strength. Cocoons are squeezed to expel water and reeled on a reeling machine. Threads from 4 cocoons are used for reeling. Those are all about the tropical tussar silkworm rearing. But yet, there is another type of tussar called oak tussar. It is a finer variety of tussar generated by the silkworm, the species called Antheria royale in India, which feed on natural food plant of oak, found in abundance in the sub-Himalayan belt of India, covering the states of Manipur, Himachal Pradesh, Uttar Pradesh, Assam, Meghalaya and Jammu and Kashmir. China is the major producer of oak tussar in the world, and this comes from another silkworm which is known as Antheria pernii. Students, now let us discuss about the cultivation of yet another silkworm type called Muga silkworm. The scientific name of Muga silkworm is Antheria assamensis. The Muga silk moth is restricted to the northeastern states, particularly Assam, is semi-domesticated and multivoltine, producing as many as 5 to 6 broods in a year. Though main hosts are Som, that is Machilus bombicina, and Sovalu, that is Litsia polyantha, it is polyphagous, feeding on as many as 18 hosts. As a result, the color of the cocoons and the quality of the silk are considerably changed. The period of the life cycle may vary from nearly 1.5 months in summer to 3 months in winter. The larvae on hatching are yellowish, but as they grow they turn to translucent green. On maturity, the larvae come to the tree trunk early morning for cocoon formation and thus can be easily collected, unlike the Antheria mylitta. The cocoons are light to deep brown in color, but white is not uncommon. Males are reddish pink, females lighter. Muga silkworm is multivoltine and 5 to 6 crops are raised in a year, out of which 2 are commercial crops. Regarding the package of practices of Muga culture, first we have to prune 15 to 20% of the plants at 6 feet height 4 months prior to rearing of early stage worm and 5 months prior to rearing of late stage worms. Then apply 30 kg of farmyard manure and NPK, that is nitrogen, phosphorus, potassium fertilizers at the rate of 44:62:17 grams per plant after pruning. Then dust bleaching powder and slaked lime mixture at the ratio of 1:9 at the rate of 200 gram per square meter in the rearing plot at least twice at an interval of 3 to 4 days before 8 to 10 days of brushing. Before 4 days of brushing, 0.01% sodium hypochlorite solution should be sprayed on the foliage of chalky rearing plot twice at an interval of 24 hours as disinfectant. Consider only microscopically examined disease-free eggs and incubate at 26 plus or minus 1 degree Celsius and 85 plus or minus 5% relative humidity. Use nylon net to protect the early stage worms from pests and predators. While fitting the nylon net, attention should be given to keep sufficient space between the net and foliage for free aeration. Brush newly hatched worms on 90 days old foliage, that is 120 days in winter, under nylon net in between 5 to 7 am on the opposite side of the sun during summer and towards sun during winter. While brushing, carrying capacity of the plant should be judged properly so that larvae may achieve fourth stage in the same tree without transfer. Consider only 1 to 3 days hatched worms for rearing. Brush 2 to 3 DFLs, that is disease-free layings per plant, through visual observation of the carrying capacity of the plant. During extreme weather conditions, that is during hailstorm, heavy rain, whirlwind, etc., brush worms indoor for 2 to 3 days in twigs kept in wet sand or in bottles containing water. Wrap the tree trunk with oil-coated polythene sheet to prevent the worms from crawling down and predators from climbing up the trees. Avoid frequent handling of worms. Use disinfected chaloni for transfer of worms. Transfer only the healthy and uniformly mounted worms to new plants. Overcrowding of larvae in the chaloni as well as in the new plants should be avoided. Periodical spray of sodium hypochlorite at the rate of 0.01% twice in each instar helps to reduce the possibility of outbreak of bacterial and viral diseases. Allow the worms to spin cocoons in bamboo box type mounds, that is with the capacity of 1500 worms per mound. Keep the mounds in semi-dark, well aerated and rain-proof room for better cocooning. Harvest the cocoons only after completion of pupation, that is 7th day in summer and 10th day in winter. Sort out good, filmy, oozy infested cocoons after harvesting. Select well-formed good cocoons for seed production as well as for reeling purpose. In this session, we have discussed about the byproducts of sericulture, present scenario of byproduct, waste, utilization and waste generated in silk sector, and about rearing of non-mulberry silkworms. To summarize these lessons, we can assure that in sericulture nothing goes waste. There is a possibility of value addition up to 40% by proper utilization of the sericulture and silk wastes. Both the on-farm and off-farm sectors of the industry have potential to convert their waste into useful byproducts of commercial value. And regarding the non-mulberry silkworms, and nowadays apart from the routine mulberry silkworm, silk filament, the silk threads obtained from tussar, eri and muga silkworms are also gaining importance for their special quality and values appreciated by a lot of people, especially of Asian countries, and fetching market rates.